Okay, this is how to factor out any type of problem that you're going to have in Algebra 1. So the first thing you're going to do is you're going to look at what all the terms have in common, also known as your GCF. Now, we've already done factoring out, but in reverse form. So if you look at it, look at your distributive property. If you have 2x times x to the third minus 4x plus 3. Remember, when you distribute, you first took that 2x to every term inside. Now, x to the third, remember, it's the implied 1 in front. So take your coefficients first. 2 times 1 is 2. X times x to the third is x to the fourth. Now, 2 times negative 4, our next term, is negative 8, and x times x is x squared. Now, for a third term, 2 times 3 is positive 6, and the x from the 2x. So this is it when you distribute the 2x. So now when you factor out, you're doing it exactly in reverse. Start with your coefficients. What does each term, what's the greatest common factor of each term? So 2, negative 8, and 6, your greatest common factor is 2. Then you look at your variables. You have an x to the fourth, you have an x to the second, and you have an x. The greatest value for each of those, remember they each have to have the amount you pick would be x. So now look at it. So now you divide. Start with your coefficient. What's 2 divided by 2? 1. What's x to the fourth divided by x? X to the third, which can also just be written simply as x to the third. Our minus sign, what's 8 divided by 2? That's 4. What's 4x? What's x squared divided by x? That's simply x. Our plus sign, 6 divided by 2 is 3. X divided by x is just 1. So now we've worked it both directions. We saw what we've done with distributing and now factoring out. Factoring out is the first step for any factoring problem. You look for the greatest common factor that's in every single term. The next step is easy enough. It's count the number of terms. So this has 2 terms. This problem has 3 terms, and so on. It's the number of terms. That's your next step. Just count how many there are, and that will tell you where you go. If there are 2 terms, you're going to look for a difference of squares. And let's go review what a difference of squares are. Remember, first this is after you've factored out the greatest common factor. So if we had x squared minus 16, how you determine difference of squares is you have to look at your first term, which would be x times x. So x squared is a perfect square, and the square root of x squared is x. 16 is 4 times 4, and the square root of 16 is 4. So 16 is a perfect square. And we have our negative sign in between. So how we would solve that is we take our first value, the square root of the first value, which is x. We take either plus or minus, whichever way you want to go first, and then the next will be x minus. And then we take our last term, the square root of that, which is 4, and that goes up into the last position for each of the problems. So it becomes the sum of x plus 4 times the difference of x minus 4. This is a difference of squares. You can only do a difference of squares if you have 2 terms. Now we're going to look at the scenarios for if there are 3 terms. The first one we're going to look for, because it's formulatic and it's very easy to solve, if it's a trinomial square. Once again, to refresh, you have to look. Let's take the example x squared plus 6xy plus 9y squared. Okay, to figure out if it's a trinomial square, is the first term a perfect square? Well, the square root of x squared is x, so yes, that's a perfect square. Is the last term a perfect square? So is 9y squared a perfect square? Well, yes, the square root of 9 is 3, and the square root of y squared is y. So they're both ends, your first term and your last term, are perfect squares. Now you have to look at the middle. You have to take your first term times your last term and double it. So put in correct order, coefficients first, 2 times 3 is 6, x times y is xy, is 6xy. That's the middle term, so this is a perfect trinomial square. So what you do for this is you take your first term x that we've already done, and we take our last term, 3y, we look at it and we see that it's all positives in there, so it's going to be plus in here, and we're going to square it. So that's your trinomial square. If it's not a trinomial square, and it's in the format of x squared plus bx plus c, and b and c stand for numbers, look at how you can factor out. Let's take the example, x squared plus 11x plus 30. So what you're going to do is, you know that x is your first term, and it's squared. So write your parentheses, and so you know they're both going to start with x. You look at both of your signs, they're both positive, so you know that it's going to be a positive for both of them. So now, all we need is what goes next to it. So we're going to look at two numbers. Our last term, remember foiling, it was the two and numbers multiplied. So we need a number that multiplies to 30 and adds to 11. If you don't remember, let's go back to foiling, because remember the two last terms in each one, this term and this term, have got to equal 30. And then when we add them, when we do our outside and our inside, those are added, which will give us the 11. So since they're all positive, it's pretty easy. Just look at all the multiples of 30. I've got 1 times 30. I've got 2 times 15. I have got 5 times 6. Those are our factors on how we get to 30. Now add them. 1 plus 30 equals 31. That's not the number we're looking for. 2 plus 15 is equal to 17, not the number we're looking for. 5 plus 6 is equal to 11. That's the number that we're looking for. So what we do is we put in our 5 and our 6, and that's how we factor out. Now, I want to look at it just a little bit different. Let's take it and let's look at what happens when we have a negative in there. So let's take x squared minus 8xy plus 15y squared. Well, remember before I said how we started? That we knew that the first term was x squared, so each one of these has to start with a value of x. But look at our last term. We've got 15y squared. So I know that y has to be a term in each one of these, and it goes at the end. Now look at your signs. You have a negative and a positive. The only way that you can add two numbers together to get a negative and multiply two numbers to get a positive would be if they were both negative. Because if you're adding a negative plus a negative, it will obviously give you a negative. And if you multiply a negative times a negative, it's going to give you a positive number. So now you're going to make a chart just like we did before. We need to multiply to 15 and add to negative 8. So since we're adding to a negative number, we know they're both negative, so just look at your terms that you're factoring. So 1 and 15 and 3 and 5. So negative 1 plus negative 15 equals negative 16. That's not our number. And negative 3 plus negative 5 is negative 8. That's our number. So we're going to take our negative 3 and our negative 5, and that is completely factored out. Let's try the third scenario that we can have. And that would be if we have two negative signs. One in the middle. So let's do x squared minus xy minus 2y squared. So once again, let's write our brackets. It's the first way to start. And we know that it starts with x squared, so I know there has to be an x value in each one of our brackets. And our last term is 2y squared, so I know there has to be a y in each of our brackets. Now let's look at what kind of symbols we're going to use, addition or subtraction. Well, I know it's negative, so you can get negative by adding two negatives or adding a positive and a negative, and the negative value being higher. But I also need it to multiply to a negative, and the only way to multiply to a negative is a positive times a negative. So now let's go back to our chart. I'm going to see two numbers that multiply to negative 2 and add to negative 1. Remember, it's negative xy, it's the implied 1. So to add to multiply to negative 2, I could have negative 1 times 2, or I could have 1 times negative 2, correct? So negative 1 plus 2 is equal to 2, and 1 minus 2 is equal to negative 1. It's our second term, so it's a positive 1 and a negative 2. Make sure you check all these as you go through them. The next one we're looking at is, once again, we're still under the category. There are three terms, but now we're looking at an ax squared plus bx plus c. So it's not just as simply an x squared, there's a number in front of it. Now, most textbooks do not show the way that I teach this, so this might not be reviewed, so I'll go a little slow. So we have, our first problem we're going to do is 2x squared minus 7x minus 4. Now, when you look at this, what I want you to do is I want you to take your first coefficient, 2, and multiply it by your last coefficient, which is 4, which will give you a negative 8. I want you to keep this number in your head, because we're going to split up this middle term into two x values that are going to be equal to negative 8. Well, when I do this, what I'm going to look for is something that's going to be compatible that I can factor out. So I know that if I took negative 8x plus 1x, I would still get 7x. So look, if I have negative 8x, and then I subtract 1x, add 1x, that's a negative 8x, plus 1x, that's going to give me a negative 7x, isn't it? So now it's where to put it. So I'm going to be working with, and start with the numbers negative 8x and positive 1. Well, I can set it up where I can put the 8x, first of all, bring down your 2x squared, and I can put the 8x right here, and then it would be 1x minus 4, but that wouldn't give anything with the 4 in common. So let me try it like this. Sometimes you have to play around with these. So let me do the plus x, then the minus 8x minus 4. When we do that, we see that it's still the same thing. If I combine like terms, I would still end up the same, wouldn't I? But now, working with 4 terms, I can take out what these first two have in common. So I can take out x, can't I? So, let's see if I can do this without any more bells. So I can do this, and that becomes 2x plus 1. Now, what can I factor out of this next group? It can be a negative 4, can't it? So negative 8 divided by negative 4 gives me a 2. Bring over my x. Negative 4 divided by negative 4 leaves me a positive 1. Now, if you don't remember your 4 terms, which we'll go to in a minute, you take your first term here, because it's being multiplied by everything in this parentheses, 2x plus 1, and our parentheses are identical, you're going to take that and you're going to bring it down. And then you're going to take our negative 4, which once again is being multiplied by the same terms, bring that down here, and that becomes our first set of parentheses. And now our second set of parentheses, since they're identical, you just write it once, 2x plus 1. If I FOILed this out, I would end up back to my original equation of 2x squared minus 7x minus 4. Let me go over the steps of that one more time. You take your first coefficient times the last coefficient, and you keep that number in your head, and then you have to take your middle term, divide it up so that it equals what that term is, but to compatible numbers that you can work with. Once you do that, then you can split it. You have 4 terms, and then you can factor out what you can from each, making sure that what is in parentheses is identical. Let's try another problem like that. Our next problem is 3x squared minus 5x minus 2. Once again, we're going to look at our first coefficient, which is 3, times our last coefficient, which is negative 2, which gives us negative 6. So I'm going to need to break negative 5x into negative 6. So I can do that if I have negative 6x plus 1x. That gives me negative 5x, doesn't it? So once again, we're going to rewrite this, breaking out our middle terms. So I have 3x squared, and I'm going to put the negative 6x first, just because 3 and 6 have 3 in common. So I've got plus x minus 2. So once again, I'm just going to start with my first set. What can I factor out? Start with your coefficients, 3 and 6. The greatest common factor is 3. X squared and x, the greatest common factor is x. So 3x squared divided by 3x leaves me x. Bring down my minus sign. 6 divided by 3 is 2. X divided by x is just 1. So now look. Now we have where this term is identical to this term. So what do we do in a situation like that? What you're going to do is you're going to just put a plus 1, because 1 times anything is just itself. That's why we learned all those properties, and this is the multiplicative identity. So once again, my 2 terms are identical. I've got my x minus 2 and my x minus 2, and they're both being multiplied by that, aren't they? So I can take this 3x, bring that down, and the plus 1, and this bracket becomes 3x plus 1. And since they're both being multiplied by x minus 2, you put that in the other parentheses, and you have solved for it. So once again, I know this is tough. I'm going to refresh it. What you need to take is your first coefficient times your last coefficient, find what that equals, and then rewrite that middle term into 2 terms that will still add back to that term, but make compatible numbers that we can work with. Okay, so now let's look at there are 4 terms. And again, we already did this when we factored the ax squared plus bx plus c. But let's go look at it. Let's take, 3x minus 6y plus 5x squared minus 10xy. So you're going to look at the terms and figure out what they have in common. So start with your first two terms. This may not always work. You may have to rearrange the terms in order to get them where you can factor things out and it will work. So let's try this. So I've got my greatest common factor is 3. So that would leave me x minus 6 minus 3 is 2y. Our next is, let's take out 5x. So 5x squared divided by 5x leaves us 2 minus 5 divided by 10 is 2. Our x's cancel out, 2y. This worked right off the bat. So now what I have, let's side this up a little bit, is, remember we are looking, as you remember before, to get these two identical. So since they're identical, I can take the term outside, 3, because 3 is being multiplied by everything in there, right? So there's our 3. And our 5x is being multiplied by everything in there. So we'll take our 5x, and we're going to make these a set of parentheses all on their own. Since they're each being multiplied by what's in that set of parentheses, let's just do the next. We just have to write that down. And if we FOILed it out, we would end up right back at our original equation. That's how you factor by grouping. The very last one that I have not talked about, and I'm not going to cover in this one, but you need to know, if you have 3 terms and you cannot factor by any of the means above, you use your quadratic equation. I'm going to cover this in another video since this is getting rather long. So we'll just work on quadratics another day, and this should help you be able to factor every problem you have.